Hi everyone, welcome back to my video. Today I want to introduce you a lesson about trigonometric angle. The first one we will explore about dialectic angle. In the plane, we have two rays, OU and OV. In the plane, given two rays, OU, OV. And ray OM in the same plane. Ray OM in the same plane. Yes. We will sweep ray OM from ray OU to ray OV. Ray OM sweeps from ray OU to ray OV. Then we have a dialectic angle. It is denoted by open round bracket OU semicolon OV, close round bracket. And OU is called the initial ray. And OV is called the terminal ray. Yes, and the measure of this dialectic angle is denoted by SD OU OV. There are two, and we know that there are two directions of rotations. Anti-clockwise is the positive and clockwise is the negative. There are two directions of rotation. Anti-clockwise is the positive and clockwise is the negative. Here, anti-clockwise and clockwise. Yes, we have some example. Find the measure of directive angles. Find the measure of directive angles by looking at figures. Number 8. This is O, U, and O, V. In the positive direction, B, O, U, and O, V. In the positive direction, C, O, U, V. In the negative direction, and D, O, U, O, V. In the negative direction. Yes, look at this one. So we can see we will start from ray OU and finish at ray OV, one circle. So we have the measure of this direction. Angle is 360 degrees. B. In B we have 1 and 2 rounds. So we have the measure of this directive angle is 720 degrees. Okay. C. By using by sweep from ray OU to ray OV in the negative direction, a half pass round, we have the measure of this directive angle is negative 180 degrees. And this one, we have a round and a half round. So the measure of this directive angle equals negative 540 degrees. Yes, it is the directive angle. Now, we will move to the next part. Unit of angle measure. Unit of angle measure and the length of an arc. The length of an arc on circle. Beside degrees, we often use another unit of angle measure is radian. So, what is radian? We have an arc AB on the circle. An arc AB on a circle which measure which measure 1 radian. If its length equals the radius r, and then we have angle AOB equal 1 radian. Okay, do you understand? Now, look at this. We know the circumference of a circle is the 2p radius. A circumference of a circle is 2 times p times radius r. Then a full circle has a measure of 2p. In another way, is measure measure 360 degrees. So we have 2p equal 360 degrees, or p equal 180 degrees. Yes, and so that we have the room to convert from degrees to radian. We have 1 radian equals p over 180 . Sorry, 1 degree radian, or 1 radian equal 180 over p degree. Yes, and we have note that we can write 3p over 2 or negative 5 instead of p 3p over 2 radians or negative 5 radians. Okay, if we don't write any words after this, we know it radian. Now we have example 2. Convert from degrees to radians and vice. Now, negative 135 degrees. B, 120 degrees. C, 3p over 4. And D, 180 degrees. 180 over 4 and 3p over 4. So, if we want to convert from degrees to radians, we will take the number over 180, then we add a p after that. Yes, then we have 3p over 4. In the same way, we will take the number 120 over 180 and add p after that. We have 2p over 3. And in example C and D, if we want to change or convert from radians to degrees, we will use p equal 180 degrees. Then we have 3 times 180 over 4 degrees. Then we have 135 degrees. In this case, we will use this formula. 1 radian equals 180 over p degrees. Then we have -5 equals -5 times 180 over p degrees. Is about -286 degrees. Yes, it is the unit of angle measure. Now, we will find the length of an arc. Number 2. A circle with vertex O and the radius R. An arc on a circle has a measure of alpha degrees or radians. Then we can find the length of arc. Sorry, we must only use alpha radians. Okay, sorry. We must note it. The length of arc is L, where L equals R times alpha. And we have example 3. A circle has a diameter 12 centimeters. An arc on the circle measures 30 degrees. find the length of an arc. Find the length of an arc. So, by using this formula, L equals R times alpha. We go to step 1. We will find radius equals 12 over 2 equals 6. And then we have to convert degrees to radius. 30 degrees equal P over 6 radian. So we have L equals 6 times P over 6 equals P. Okay, you understand? Yes. And the next part we will explore is about a unit circle and trigonometric values. A unit circle. Unit circle is a circle with vertex O, radius R equals 1, and it is an oriented direction. With a point A with a coordinates 1, 0, serving as an origin of unit circle. Yes, radius R equals 1 and an oriented direction, so that it means the positive direction is anti-clockwise and the negative direction is clockwise. Okay. A point in on a unit circle that represent the measure of alpha. A point on a unit circle that represent the measure of a dialectic angle is point M on unit circle, such that the measure of the dialectic angle OAOM measure of a directed angle depends on the terminal point M on the unit circle. So we have example 4. Find points M and on unit circle that represents angles 135 degrees or negative 2p over 3. Yes, to do this, look at, I have a unit circle. We start from ray OA in the positive direction. That the measure of directed angle OAOM equals 135. So we have this. And here is the positive position of point M. In the same way, in the negative direction, we start from ray OA and we measure this directed angle is negative 2p over 3. 1, 2, 1, 2. So we have this one about, if we convert to degrees, we have negative 120 degrees. So we have this. Okay. This is the position of point M. It is about the unit circle. And we have 4 vertices: A, A prime, B, B prime, A1, 0, A prime, negative 1, 0, B0, 1, and B prime, O, negative 1. Okay, and number 2, we will explore about trigonometric values on unit circle with point M with coordinates x, y, x, and y. In this point, the x coordinate is called cosine of Okay, and this axis is also called axis is also called cosine axis, and the y-axis is also called the sine axis. And sine alpha and cosine alpha is defined for all value alpha, and -1 is less than or equals to sine alpha or cosine alpha less than or equals to 1. And if cosine alpha is different from 0, then ratio sine alpha over cosine alpha is called tangent of alpha. It is denoted as tan alpha. And if sine alpha is different from 0, then ratio cosine alpha over sine alpha is called cotangent of alpha, and it is denoted as cotang alpha. And sine alpha, cosine alpha, tangent alpha, and cotangent alpha are called trigonometric values. Okay. Trigonometric. And we also have sine alpha plus k times 2p equals sine alpha, because we can see in these figures. Yes, with the same rate OUOV, we can have infinitely many directing angles that have the same initial rate and OU and the same terminal rate OV in A and B, or C and D. So we can write this equals cosine alpha, and tangent alpha is defined when alpha is different from p over 2 plus k tan p, k in the integrals, and cotangent find when alpha is different from p plus k times p. K is in integers. And next, we will explore about part 4. Basic trigonometric formulas. Trigonometric formulas and relationship between a special directed angle. Okay, number 1 we will explore is about basic trigonometry formula. Sine squared alpha plus cosine squared alpha equals 1. 2. Tangent alpha multiple by cotangent alpha equal 1. Number 3. 1 plus tangent e squared alpha equals 1 over cosine squared alpha. Alpha is different from p over 2 plus k times p, and k is in the integral. Number 4. 1 plus cotangent squared alpha equal 1 over sine squared alpha. Alpha is different from p plus k times p. K is in the integrals. It is a basic trigonometric formulas. And some special directed angles. We have that two opposite angles. Opposite angles. Two opposite angles has the same values of cosine. I will write it by red. Cosine negative alpha equals cosine alpha, the same value. But if it is sine or tangent or cotangent, all of this will have the negative values. Negative sine alpha, negative tan, tangent alpha, cotangent alpha, negative. Two supplementary angles. We have sine p minus alpha equals sine alpha. But if it is tangent alpha. Yes, next. Two complementary angles. Two complementary angles. If we have sine p over 2 minus alpha, so the result is cosine alpha. And the same way we have cosine equals sine, tangent equals cotangent, and cotangent equals tangent of p over 2 minus alpha. And this one is alpha. Okay, and the last is two different by p angles. We have tan and cotangent or cotangent of p plus alpha. But if this one is sine p plus alpha equals negative sine alpha, and cosine p plus alpha equals negative cosine alpha. Yes. And with for trigonometric formulas, we will applying in some example. But first one, we will find the sine of trigonometric values. The size of trigonometric values. Come back to a unit circle. I have a unit circle. With origin 8, we can see that this unit circle is divided into four parts. We call this is first quadrant, second quadrant, third quadrant, and fourth quadrant. And it always has a positive direction and negative direction. Yes. And look at this figure. We will have the signs of trigonometric values. X-axis or cosine axis, y-axis is also sine axis. Yes, and the sign of them is from O to the positive. We have cosine alpha will greater than 0. This and less than 0 from this. And the sine alpha is greater than 0 from this and it is less than 0 from this. Okay. And now we can see in this picture is that by using the table and the tan, the sine, the size of tangent alpha and cotangent alpha depend on the sine of sine alpha and cosine alpha. If sine alpha and cosine alpha have the same sign, then tangent alpha and cotangent alpha is greater than 0, and vice versa. If sine alpha and cosine alpha have the difference sign, then tangent alpha is less than 0, cotangent alpha is less than 0. Okay, and we will have example 5. Find trigonometric values of alpha. No. A. Negative 3p over 2 less than alpha less than negative p and sine alpha equal 3 over 5. To find all trigonometric values of alpha, first, we must find the size of them. Then we will use basic trigonometric formulas to find another. Now, step 1, we will find the sine of cosine, because if we have the sine of sine alpha and cosine alpha, then we will have the size of tangent and cotangent alpha. Step 1, we can see that alpha with this measure, we can see that in the negative position, direction, O negative P over 2 negative P negative 3P over 2 and negative 2P. We can see that alpha belongs to the second quadrant. Alpha belongs to the second quadrant. Implies cosine alpha is less than 0. Step 2. We have sine alpha, so we can use number 1. Sine squared alpha plus cosine squared alpha equals 1. cosine alpha with the sign is negative square root of 1 minus sine squares alpha equals negative 1 minus 3 over 5 squared equals negative 4 over 5. After we have sine alpha and cosine alpha, we can use the formula tangent alpha equals 3 over 5 divided by negative 4 over 5 equals negative 3 over 4. And cotangent alpha, we can use number 2 formula, 1 over tangent alpha, and it equals 4 over 3. Yes, this is the example 5A. B. We have tangent alpha is equals 2, and P less than alpha less than 3P over 2. We can see that we sweep out the derivative angle in the positive direction. Now, the step 1, we will find the sign of sine and cosine. Now, I have 0 P over 2 P 3P over 2, and this one is 2P. And easily we will find that alpha belongs to the third quadrant. Alpha belongs to the third quadrant. Implies sine alpha is less than 0 and cosine alpha is less than 0 too. Next, with tangent alpha equals 2, we easily find cotangent alpha equals 1 over tangent alpha equals 1 over 2, or a half. Yes, next, we will use number 3 formula. Yes, we have 1 plus tang squared alpha equals 1 over cosine squared alpha, so that cosine alpha equals negative square root of 1 over 1 plus tangent squared alpha equals negative square root of 1 over 1 plus 2 squared, and the result is 1 over square root of 5. And we can use this one. Tangent alpha is equals sine alpha over cosine alpha. Okay. Then we have sine alpha equals tangent alpha multiply cosine alpha equals 2 multiplies negative 1 over square root of 5. And we have the result is negative 2 over square root of 5. Yes, and this is all of the content of our lesson today. And I will finish it this. Thank you for your participation. Okay, thank you very much.